Assalamualaikum. Hi, my name is AISHAH and today I will present to you about a project that me and my partner, DEANNA SOFEA, has been working on. Unfortunately, she is absent today due to the issues of COVID-19 pandemic. But anyway, so first of all, have you ever had a wound such as cuts or scratches that takes quite a long time to heal? Well, this is what our project is about, entitled Alocasia denudata Cream Formulation, based on our research, which is stimulation of wound healing activity of Alocasia denudata tested on DF1 chicken fibroblast cell. So, first of all, what is Alocasia denudata? Well, it is commonly known as yam, or locally known as Kladi-Chande or Kladi-Chane, and you can find this type of plant in rural parts of Malaysia such as Kelantan and Terengganu. Now this plant here, it has been used as traditional wound healers for a very long time, but it has never been commercialized. In our research, we hypothesized that Alocasia denudata can stimulate a wound healing property, meaning that it can heal wounds. So next, we have three objectives in our project, which is first, to determine the cytotoxicity of Alocasia denudata when tested on the F1 chicken fibroblast cell. Second, we want to determine the suitable concentration that can proliferate the most cell migration. And lastly, we want to determine the chemical profile, anti-diabetic agent, and also heavy metals in Alocasia denudata. Okay, and next. So for the methodology, we started out with the sample preparation, where the stem of Alocasia denudata was taken and cut and put into a squeezer to obtain its juice. It was then centrifuged to obtain its stem crude extract only, as you can see here. And it was put into 7 different concentrations for us to move on with our next procedure, which is the MTT assay. This MTT assay here is for us to determine our first objective, which is we want to know whether Alocasia denudata has any cytotoxicity effect. So, for the results, you can see here from the MTT assay, the 7 concentration that we used was 2000, 1500, 1000, 500, 250, 50 and 5 microgram per milliliter. And based on the results here, it showed that at the highest concentration, which is 2000 microgram per milliliter, it shows 74% of cell viability, meaning that there is no cytotoxicity at all in Alocasia denudata. And if you can see, at the lowest dose, which is 5 microgram per milliliter, it shows 110% of cell viability, meaning that not only it doesn't have any cytotoxicity, but it even promotes more cell migration, which is as much as 110%. So from that, we have achieved our first objective, where Alocasia denudata does not have any cytotoxicity effect. Next, we moved on to the cell migration assay. Now in this assay, the scratch was scratched. The cell of the chicken was scratched to stimulate it as a wound, and we tested it with 2 types of concentration, which is 1000 microgram per milliliter and also 5 microgram per milliliter. And we tested these treated cells with the control cell, which is the untreated cell. So next, you can see the results here. This is when the cell was tested with 1000 microgram per milliliter. From here, you can see that there is positive migration throughout the 36 hours. But if you compare it to the control, which is the green one here, at the end of 36 hours, it shows negative growth. And here is the graph for 5 microgram per milliliter. It shows an even higher migration rate comparing to the 1000 that I had shown you just now. And for the control, it shows negative growth throughout the 36 hours. And here is an image of the cell that we captured using an image J for you to see clearer. For 1000 and also 5 microgram per milliliter, at the end of it shows that there are more cells, meaning that the scratch cannot be seen because the cell has been migrated. But comparing to the 1000 and also 5 microgram per milliliter, 5 microgram per milliliter, which is the lowest concentration, shows even more amount of cell comparing to 1000. Complementing the graph that I have shown now, and comparing to the control, at the end of 36 hours, the cells have scattered, meaning that there is negative growth. So after this, we have already achieved our second objective, that 5 microgram per milliliter is the best concentration that can proliferate the most cell migration. We then continued to make the Alocasia denudata cream formulation, which is this cream right here. So what we did was 18 grams of Alocasia denudata were weighed and blended using a blender along with 250 grams of water. And the blended Alocasia denudata was then put into a pan with a temperature of 60 degrees Celsius. It was added along with 6 grams of half-go and also 2 grams of cathan, which is a preservative. And the mixture was mixed until it formed a cream base, which is this cream right here. So, to prove our third objective, we tested this Alocasia denudata cream formulation with 3 types of tests, which is chemical profile, anti-diabetic agent, and also heavy metal screening test. So here are the results for anti-diabetic agent screening. We found out that there is no detection of any anti-diabetic agent at all, which is okay because after we did the heavy metal screening, it is found that there is also no detection of any heavy metals in this cream formulation, meaning that this cream is safe to be used. And lastly, when we did the chemical profiling, which is the most important test, we found out there are 3 main active compounds present in Alocasia denudata, which is lauric acid, fumaric acid, and also benzoic acid. And it is found that all these 3 acids help in the inflammation phase, in the wound healing phase. And among these 3, lauric acid is the most concentrated, which is as much as 22.41%. And this is very good because lauric acid helps in the second phase of wound healing, which is the inflammation phase. So from our project, the novelty is that we used controlled concentration of Alocasia denudata. And this brings an advantage because making this cream was easily made and it is organic, bringing up to our commercial value where it is cost effective to be produced comparing to other creams that use chemicals and also synthetic drugs. So for our further research, we want to pursue on to test this Alocasia denudata onto human dermal fibroblast cell. And we also want to pursue on with clinical tests, as well as we want to commercialize this Alocasia denudata cream formulation for the use of the society. So in our project, we can conclude that Alocasia denudata does not have any cytotoxicity effect, and it is proven to be safe to be used since there is no heavy metals detected at all. So this cream here is safe to be used. So throughout doing our project, there are a few things that we have owned, which is first, we have owned the patent number for our product here, Alocasia denudata cream formulation. We have owned the copyright number for our research. We have won the gold medalist in National Tuna Scientist competition, and also we have received grants by Mara Education Division. So that is all for our project. Thank you very much.